be misaligned and wearing, right?
Yeah.
I thought that's what you meant. I mean, I could grab some gears and show you if you want me to illustrate that. Is that going to make it clearer, or can you really... Guys, where I'm going with this, I want you to be able to envision this, all right? Imagine this shaft, instead of being parallel, is now canted.
Hold the pressure on one side.
I'm loading this half or this side of the tooth. I'm effectively loading it. What do I mean by that? Think about two gears that are now, instead of being like this, look how my fingers are engaged. And I do this.
You can start snapping the ends off.
As soon as I start hitting a lot of load or a sudden stop or something, cha-ching. Let's go gauge on the ones that didn't break, right? Then I'm going to get back around to those that are start chipping, and those pieces where they break off, they're real sharp, and they probably will maybe promote quicker wear then where they start engaging. And this just really snowballs at that point, right? That kind of makes sense? These are the questions I expect you all to do. Why? Remember that why and how thing? That's what I want you to be able to, I want you to start doing. All right? I want you to have a good understanding. If I'm grabbing a set of gears, which I should have some here, right here's two examples. I mean, if you put those together and they're nice and straight, you can feel how well they engage. But then angle them a little bit, and you can almost feel it trying to work against each other. What do you think, Jason?
That's pretty cool.
You can feel the difference. See, I'm not just...
properly like that. And then sweet.
As soon as you angle it a little bit, it almost feels like it's working against itself. But when it's properly aligned, it works well together. The other thing to keep in mind, if I go in the stock room and I don't pay attention to the pitch, tooth pitch, and I grab the wrong one, it may go together if it's metric and one's metric and one's standard or something, or somehow you had some off the wall special ordered pitch and it was close but it wasn't a perfect match. Not long for this world, because you can feel when they match, you can feel how well they work together. All right, here we get into helical designs. Can you see how the teeth are cut at an angle? Now, what would be benefit about a helical design?
Better lubrication, distribution of lubrication, maybe not.
All right, well, I'll throw something else out there.
Increase the strength with it now.
Think about it. What's the shortest distance across something? Straight across, right? So, if the shortest distance is straight across, if I now cut it at an angle, am I still achieving the shortest distance, or did it get longer?
It's getting longer.
So, do I got a longer or a wider tooth at that point?
You do, so yeah, I guess it would increase the strength. I see what you're saying. Yeah.
If you look at race cars, a lot of race cars will have helical
Rears are like that.
gears in the trannies. You have the same width gear, but by angling the tooth, you got a wider tooth across that surface area. You can create problems, yes. Dalton asked, he said, can we create problems if we cut it at too sharp of an angle? Yes, we can, because when we get too sharp of an angle, then the gears want to be run at an angle. Instead of parallel, they want to be angled to one another at that point because of the amount of cut in the tooth. All right? Now look at this. Now, believe it or not, They actually have a timing belt that looks like that. That the rib on the back of the belt is actually cut in a V. They claim that they last longer and they're quieter. Never tried any of them, but I had a representative bring them in before I left Family Dollar. And that's old herringbone. Now we get the internal gears. Where do we see that at, Alex? Come on, quick. Internal gears? What's behind the head and behind the block?
Transmission?
There you go.
Mine decided.
Depends which side you're standing on. See how messed up it makes you when you got that front wheel
It
drive?
might be in front of me
You can't-
then.
See, it just ain't right, is it? Who was it started? Olds, didn't it? With the old,
What those Mazda, they're rotary motors like that, isn't it?
yeah.
And,
I'm talking about the front wheel drive. Who was it? Olds or,
yeah, the old Bill 88, wasn't it?
yeah, no, Tornado.
Tornado, that's it.
Yeah. You ever see the Tornado had the two front ends on the same car?
I saw one around here.
Guy took two halves, two front halves of the car, welded them together.
Gotta do what you gotta do.
Look at this setup. How many watch monster trucks? How many have ever seen the monster trucks? And you've heard of those planetary gears that they have in those 1 ton and 5 ton rears underneath the front of them? You might see something like this in those. They handle a great deal of torque. Figure you got motors on those things making 11, anywhere from 5,000 to 11,000 horsepower. They can't afford to run those 11,000 horsepower jobs too much. Now you're getting into top fuel dragster area. But anyway, that's what the planetary looks like. And it even tells you right there, look at that. I didn't even read it below it. Planetary gear drive. All right, now that they've run you through all the different types, or a lot of different types of gears, we're getting into, again, breaking down the components of a gear. Probably rather important that we know that, right? And they're going to go through every aspect of where to measure and what each component is. Now, I'm not going to quiz you on each component, but there are certain things that I'm going to expect you to know. And the other thing that I'm going to throw out there, expect to have a quiz on some of the basic ratios, like when I go to level a motor and I get that filler gauge out and the ratio that I need to use, it might be important to remember. Used it a lot, right? So some of the exercises we've done, those things that's gotten real repetitious, might be key things to keep in mind. Because here in about a week, well, we're going to do a midterm, and that's what it's going to be on. All right? And we'll do a little review before, I'm not going to hang you totally out to dry. All right? Maybe Alex, but not the rest of you. All right.
Actually, he's got a performance machine.
Huh?
He's actually got a performance machine.
Alex did?
His.
Oh, well, that was nice of him. So y'all gotta look out for him then, right? I said you gotta look out for him. You don't throw him under the bus then, right?
I don't think so.
You don't play favor. Oh, my.
They throw everybody on the bus.
Hmm.
Maybe.
Oh. Well, Dawn, you're gonna lose a lot of friends this
So
way.
he's
You
making
gotta be
friends by the
careful.
handful, ain't he?
Man. All right, guys, again, it's here, I mean, this previous box here, and then this one, they want you to go through and label the different parts. Again, I'm not going to expect you to have it memorized, but I do want you to do the exercise so it's at least in the back of your mind, all right? Makes sense? Another term that you're going to see come up in here, if it hasn't already, because I'm going through it pretty fast, it's called backlash. Does anybody know what that is? If you do, raise your hand other than Mike.
I know what it is, I don't know if I can explain it.
I thought Dalton raised his hand. Well, shoot, now, if you got team effort, because Jason said he knew. Wash it down.
I'm trying to think of, like when you disengage gears and you have pressure go forward and they jump back.
All right, but what creates the backlash?
I got, yeah, full singers.
See what I'm doing? This will be zero backlash, right? You don't see any gap in there, right? Is that what you're trying to explain? Or are you thinking about, I got preload on here, when I release it, it jumps back? Backlash is actually the distance between the teeth that I have for play, because I need to allow for expansion within heat, right? Because what happens when metal heats?
Expands.
Expands, so it means it's going to grow in size, right? Everybody agree with that? I know you do, Mr. Kelly, right, sir? Yes, sir? Sir, yes, sir?
Yes.
And what's the other thing we got to account for? Do we have to leave any clearance for something called lubrication, maybe? Is that kind of important? Maybe? Is it?
I didn't know you need to leave a clearance for that.
Tell you what then. Take your motor apart. It's in your car. Go to zero clearance on the rod, just on the rod bearings. Zero clearance. And put it back together. Only run it for 5 minutes, if it runs that long.
So you actually leave a space?
Most engines, about 2.5 thou is left. It could be as much as 4.5. On the thrust side, it could be probably 6 thou. On the crank, you use what they call plastic gauge to determine. Unless you got, bless you, unless you got pop gauges. Didn't know that.
Never really thought about it.
You get into building motors, you'll find out. Isn't that right, Alex?
I just tore mine apart yesterday.
Find anything you didn't know was in there?
I looked really good when I tore it
Huh?
apart. Said everything was perfect when I tore it apart.
But did you find pieces you didn't know that existed, or did you already know it all?
I didn't know.
Oh, I better move on then while you know it all. Now, but to answer your question, yes, you leave clearances for oil. And that's, within an internal combustion engine, that's on everything. Generally there's a slight bit of lubrication left, even when you're putting it together. You'll lubricate everything that you're putting together. Well, there's a sheen that happens on the side of that piece. And even though you don't see it, there is the smallest clearance because of that oil in there. I mean, think about the thickness of 2.5 thou.
If you had a shaft, you coated it with oil, a thin layer, like a thin layer of oil, grease, whatever oil. I mean, would the calipers pick that up? Probably
No,
not.
because you squeeze it out.
Yeah.
Well, I'll challenge you this. As soon as we get a lathe in here, we'll machine a bearing and have it be almost net fit, where you can just, and generally, believe it or not, you need almost 1,000 clearance to slide two components together. John, I mean, you've been there. But we'll make it as tight a fit as possible, and you oil the shaft up, and then slide the shaft through the bearing and see what happens. It'll skim the oil off the surface of the shaft. Happen every time. And depending on the clearance, you pass the shaft through a bearing, it'll be dry coming out the other side. Now, how many have ever took a bearing, put it in hot water or on heat, just a small amount, and then put the shaft that was going on in the freezer? Somehow I knew he was gonna raise his hand. Been around the block a little bit.
That's a good idea.
I may die as he stress highlights.
That's a pretty smart idea. I like
Yeah,
that.
I had old man May's machine shop taught me that.
I've been doing that for years. Matter of fact, I had a distributor that froze up one time, and I took a CO2 fire extinguisher and shot that distributor with the CO2, and had the motor running, so the block was hot. I was able to pull that distributor right out of there. If you'll notice, under our mechanical benches, there's a plate heater over on the one that's on the west side. On the east side, when there's actually a cone heater and a plate heater for bearings. Now, you might be a little confused as to what I'm talking about here, but that's a bearing heater. Y'all probably thought that was a popcorn machine or something. Nah. Orville Redenbacher didn't have anything to do with this. All right, that's a bearing heater. I know Chris knew that, right, Chris? Now, what someone stored all of our gloves on is actually a plate heater. And you actually set an arbor on here. And if you look, it reads bearing heater arbor. I'd set that on there and I'd slide the bearing on it. That would transfer heat up into the bearing. I would take those gloves, grab the bearing, right down over the shaft. If I wanted it to be even easier, I'd take the shaft and put it in our small little freezer in there for just 10-15 minutes. And then the heated bearing and the frozen shaft, I'd almost have to hold the bearing where I wanted it for a couple seconds so it didn't just fall off. Us old fuddy-duddies do have a couple tricks still up our sleeve. All right. So anyway, backlash. The gap or the play, and generally we measure that in thousandths, will hold the axle or will hold one of the gears in a fixed location and we'll move the other one. And we'll actually have the dial indicator there to see how many thousandths of movement I'm getting out of the other gear. All right? That will most likely be one of the exercises that is performed in this upcoming set of exercises. Identifying dimensions. I'm going to start moving through here pretty quickly. It's still, again, breaking down more componentry, where the pressure points are, operations of a spur gear. Again, getting into the fit and proper engagement. Look at that term. Oh! Right there it is. See how it's showing you right there? For those that set up differentials, you'd actually take and put white grease on the ring gear, and you'd run it to make sure that you have proper engagement of the tooth, where the pattern was actually making contact on the ring gear and backlash. All right? There you go. Remember, it's talking about gear alignment. Obviously, this alignment, look at that. How long do you reckon that's going to last, Mike? Not long at all, is it there, Mr. Pearson?
Oh, why not?
This one will probably run a while, right here. This one, again.
Not even contacted, I want for a very long time, actually.
Yeah. Might not perform much work, but it's going to sit there and gears not going to wear out, are they, Jeff? That dude wanted to save some product, didn't he? Ah, there's our best friend, that straight edge. Alright. And this is one of the actual apparatuses you'll find on there. This is a variable speed gear motor, alright? And there's one on each bench. And that one you can actually change the speed of the motor. Alright? And here comes your exercises. So, they're not that difficult. You can complete it without much, but you do have to check the backlash, guys, when you're setting these up. There's more formulas there. Everybody understand? There's your dial indicator, so you can actually see how much backlash you have. They're going to hold this one still and move this one. All right? Pay attention. Very seldom have I ever seen anybody do an arm backlash, so it's always done on the tooth. And there you see the proper setup. They're going to hold this still and move this one. All right? And trust me, when you get into that, you're going to end up moving gears and moving this one, moving that one, and you're still trying to keep everything straight. You get the proper backlash. Because this will give you a range to have the backlash in, as will other applications. All right, guys, that's it. Have a good evening. Any questions?
Fluid power.
All right.
Oh, yeah, 1 o'clock.
All right, guys, have a good evening. How's the mountain on the way over?
I didn't come that way. I had to run to the banks, I went down 9, 10.
Where they got it. Was you sleep when you came to Edgefield?
Well, what
Not bad, but yeah.
It was fun out there, and I got.
Yes, sir.
More rain.
Any more about
I
the
don't know where
tools?
it rain.